So let's keep trucking. Let's talk a little bit, tiny introduction to astronomical distances. Astronomical distances are just ways of measuring distance. We could use kilometer and mile, but it gets wonky because even in relatively short distances in space, we're now talking about millions and billions and trillions, and it gets confusing really, really fast. So we have totally new units. Astronomical units are most useful. So we're going to define astronomical units. And these are going to be most useful in the solar system and close to the solar system. And not just our solar system, but any solar system. Okay. And this is the average distance between Earth and the sun is 1 astronomical unit. Well, that's really, really useful because then you can talk about like, oh, Neptune's 20 astronomical units out. Okay. It makes a lot of sense. It's a sensical. Now, if we were going to try to apply this to much bigger things, like when we're talking about something that's like a couple of light years away, now it's going to start getting wonky again because we're going back into the like thousands of astronomical units. So we have another one for the distance between stars. So this is the distance light travels in a year. And it is useful for measuring between stars. So not all of these are going to be used in every place, but when we're talking within the solar system, close to the solar system, like the Oort cloud. The Oort cloud is the furthest distance out realm of comets. It's basically the outermost edge of the solar system. Still useful for talking about astronomical units. But when we start talking about like, you know, stars, even when we're talking about very, very close stars, like, you know, Alpha Centauri and stars like that, it would still be awkward to talk about thousands and thousands of astronomical units. So we use light years. Now let's talk a little bit about metric prefixes. We're going to be using metric because this is a non-geology science course. If you take my geology course, you will learn that geology is one of the few sciences that actually switch hits with English measurements. But astronomy, they're only metric. We don't ever use feet, that sort of thing in astronomy. So getting a little used to metric prefixes is helpful in metric units in general. So prefixes are added on in order to give you units, okay? Or give you size of how much bigger one unit is than another. So this will be easier once we get practice with it. So let's first try to understand, this is another powers of 10 thing. I'm going to start right here with the 1. There's no prefix here. This is often referred to, 1 is often referred to as the unit. Okay. So, and that is just 1. And 1 expressed in powers is 10 to the 0. Now, deca is 10. And 10 is expressed as 10 to the 1. Hectare is 100, expressed as 10 to the 2. Kilo is 1,000. And we would say that that's 10 to the 3. How did we get there? So we can get there 10 to the 3. If you're still not super comfortable with this, we saw it in that scientific notation video, and we talked about it, like kind of touched on it a little bit with that intro to your first question in this workbook. But another way we can do this, 1, 2, 3, we move that decimal point 1, 2, 3 spaces so that 3 becomes that 3 over there. Okay. Same thing too with mega. You can just count up the zeros. Mega is a million, so that's a million is 6 zeros. So because that's 1, 2, 3, 4, 5, 6 zeros, that would be 10 to the 6. Giga is 9 zeros. Giga is a billion. A billion is 9 zeros. 10 to the 9. Once again, if you are a calculus type person, trillion is tera or 10 to the 12, or 1 with 12 zeros. If you are someone in calculus and you're like, oh my gosh, Dr. E, I remember this class is friendly for everyone. So don't be afraid to like fast forward and pause and that kind of stuff. But it's helpful to talk this stuff through a little bit and walk through it. This is one of those ideas that'll be valuable in any science or math course that you take. So now moving in the other direction. Okay. So if we go, take out my handy dandy, I'll use this as my straight edge. So if I'm moving from my units, from my 1, going in this direction, we have a positive exponent. In other words, the little number on top of the 10 is, I can spell exponent. Who says that I can't? A little number right next to the 10 is positive. If I'm going in this direction, let's use a different color just for fun. I got lots of colors here. Ooh. There we go. Here we have a negative exponent. Okay, so positive exponent going in this direction, negative going smaller than 1, fractions of 1. So deci is 1/10. That is 0.1. Okay, now how to figure out one way to figure out to the 10th, we can see that this goes this direction, 1. Okay, 1 to the right, just like it was talking about in that video. That video was, it's actually a really good video, that Math Shorts video. Feel free to rewatch it. And we can see that's 10 to the negative 1 based on this jump backwards of 1. Okay, centa, same dealy. 1, 2, because we're going to get behind the 1, take that decimal point and move it behind the 1. You have to move 1, 2, and that becomes negative 2. Now we can do that with milli and micro and nano. Another way to look at this, though, I'm just going to show you that there's a symmetry here. So in this symmetry, what I notice is that, like, for example, 100 is 2. 100th, so 100, in other words, 100, is to the 2. 100th is to, in other words, 1 over 100 is to the negative 2. So there's that symmetry here. Okay. So we can use that symmetry to figure out our numbers for 1,000, 1 million, 1 billion. So I'm just going to put 10 here to prep myself. So I see that my 1,000 over here, this is another way of looking at it. If you learned a different way in math class, don't be afraid to use whatever you're comfortable with. But see that this is 1,000, so I'm going to take that 3 and say, okay, when I have 1,000th, that means that it's going to be negative 3. Okay. When I have 1 millionth, 1 million is 6. So when I bring it down here, 1 millionth is going to be 10 to the negative 6. Same with a billionth. Billion is 9. And then I'm going to bring it on down. It's going to be 10 to the negative 9. Okay. Now, how do I write that out? I can use that same tool about the hopping decimal point going in this direction. So I'm just going to start with a 0 point and now say -3. So that means that I need to go, where's my blue pen? There's my blue. It's actually teal. 1, 2, 3. So this is where the decimal would be behind the 1. So in this 1 right here, there's a 1 right there, right? In that first pocket there. And then I fill the other pockets with zeros. So .001 is 10 to the -3, 1,000th, which would be milli. Same 2, let's do it with millionth, 0 point, and that's 6. So I'm going to do 1, 2, 3, 4, 5, 6. Put that 1 right there. 0, 0, 0, 0, 0. Okay, so in between the 1 and the dot, there's 5 zeros because we're going behind the 1. And then we'll do the same thing with a billionth. 0 point. We're going -9, so 1, 2, 3, 4, 5, 6, 7, 8, 9. I can barely fit it. Here's a 1, and then I fill all the rest of those little pockets with zeros. All right. So this is giving us some idea of scale, okay, in the universe and anywhere. This is, once again, one of those little review things that your book doesn't really go into in this section, but since we're going to, it kind of presumes that you know this. I'm not presuming that you know this. So if you do already know this, my apologies. Actually, no, be nice to your fellow classmates. I'm going to tell you most of you don't know this. And if you did know it, you don't remember it. So that's what I've discovered from teaching this stuff in person is like, even if you knew it, you don't remember it. Now, not every single one of these prefixes are we going to use all the time, particularly hecto, deca, deci. We don't really use that. Okay. We use the unit, okay, measurement, no prefix, quite a bit. And then going up, we tend to use kilo in everyday language, like when we're talking about like kilometer or stuff and that kind of thing. And then in astronomy, we use a lot of mega, giga, tera, okay, because we're often talking about millions, billions, and trillions. Similarly, going in the other direction, in everyday language, like if you're the kind of person that's using, like just doing practical everyday thing, a centimeter is approximately like used a lot like an inch is because there's about 2.5 centimeters in an inch. So centa and millimeter are ones that are going to come up a lot in everyday talking. And then in astronomy and other sciences, these really tiny, these micros and these nanos, when we're talking about things like wavelength and that kind of stuff, are going to come up. So these are the ones you're going to see the most. Now, how am I going to actually use this? How am I actually going to use these values? Okay, so as an example, and for an example, we're going to highlight our examples in this class. It's going to throw some people off because usually it's blue, but I don't have a blue highlighter this semester. I have a pink one. So we're going to make pink our example color. So for our example here, we're going to go with, we're going to say, okay, our unit distance is meter. Okay. So that's our unit distance that we're starting with. A meter is about the size of a yard. In other words, a meter is about 3 feet. So if you're having trouble visualizing that. So a kilometer is equal to 1,000 meters. A centimeter is equal to 1/100th of a meter. Okay, or we could say 0.01 meters or 10 to the negative 2 meters, any of those. So this gives you a little bit of an idea. Now, if this is super foreign to you, if you have never seen this before in your life, reach out and we will work on it together. So let's take a look at a good example down here. I've noticed it bleeds through a tiny, tiny bit when I use a highlighter, so I gotta be a little bit careful. So how many bytes does a terabyte hard drive store? So let's actually try to figure this out together. So what color pen should I be using for this? I use green, pink, blue. I haven't used red yet. So, but that's usually definition. So I'm going to use orange again. Oh no. So how many bytes does a terabyte hard drive store? So I'm going to circle that terabyte. And then, so this byte part right here, this would be my units. Okay. And this right here, tera, is my prefix. So this is the same thing. This is saying how many, according to this prefix, how many bytes does a terabyte hard drive store? And if you go up to our little diagram over here, we can see this tera over here. Read across, that's a trillion. So our answer here would be it stores 1 trillion bytes. Ooh, don't give up on me now, pen. I'm going to need you for a whole semester. Okay, there we go. Email me if you've got questions. Let's keep right on trucking.